Thanks for tuning in today. Ladies and mostly gentlemen, we have our third installment of the MiniPro Dyno assembly and testing. Today I had to prep for about an hour, but we are ready, so let's get into it. All right, so today I had to spend about an hour getting ready for this video. There was a lot more installing of certain drivers to do, which is located in the instructions. I had to break down and read the instructions, which, not too big of a deal. It actually didn't go into how to use the software in the instructions. Maybe there's another set that I didn't find, but stumbling through the software is a little bit difficult at first, but we figured it out. So now all there is to do is to actually use the dyno. So we've got all kinds of fancy blinking lights and everything going on. I have my MiniPro Dyno for Windows version 4.2.1 installed on the computer. I have two USB cords plugged into my computer for the little controller that controls my ESC, and then for the actual dyno spitting out information. So we're gonna get to it by plugging in first. Maybe you could hear that in the audio. Give our two beeps for the 2-cell lithium polymer battery, and then the arming chimes from the TorqueMaster BRXL ESC. I'm only going to test this on 2S LiPo at first to see how it does. And it's pretty straightforward. So you can see on the screen here that I'm going to go over to start sequence for test 1. If we look right below that, it actually shows you what it does. And stock, it usually starts up with about a 30% throttle for just a little bit to get it all going, and then it jumps up to 100% throttle to make sure that it doesn't beat the belt in too hard, I'm assuming. But I want to beat the belt in as hard as I can. Let's see if we can make it skip. So get ready to go. Start sequence test number 1. Oh, are you sure ready to set the parameter? Yes, I am sure ready to set the parameter. All right, so she's kind of loud. This board is amplifying everything. It's, all right, and you can see up on the screen now, we have our first dyno capture. That one had a little bit of a spike at first. So let's start test sequence number 2. Are you sure ready to set the parameter? Yes, we're sure. Yeah. All right. So if you can hear me over this loud son of a gun, the second test was pretty much the same. It starts a little later in the RPMs. As you can see, it starts, like 3,000, 3,500 RPMs, and truncated that first section of what I would consider bad data. So let's just do another one. Any burning smell yet? Nope, we're good. We're good. We're going to continue on. Are you sure ready to set the parameter? Yes, I'm sure ready. All right. So we have 3 tests on the screen that you can see by looking at the screen cap, and it looks like the first test and the third test had a little bit of just errant data on there. So what I'm going to do is remove those, and then we can look at this nice pretty graph. Maybe I'll look at some other graphs too. Yeah, there's a little bit of errant information on this, especially on that first pull. We'll just remove those, and you can see that information is not really, I wouldn't call it accurate, but what we would do is just kind of truncate from 4,000 RPM on and consider that our useful data test, which is pretty much test number 2. So if we look, what we are probably going to see on a permanent magnet motor is that about halfway through the RPMs, we will see a peak on power and torque. And looking at this, yes indeed, so we top out, yeah, it probably looks like 13-ish thousand, 14-ish thousand RPM. So we should see a peak around the 7,000 to 6,500 RPM line on the torque. And yes indeed. And the reason that is when you pin the throttle with full voltage on a permanent magnet magnet motor, it's pretty much at stall when it starts. As it starts to spin, the efficiency of the motor goes up, and as the efficiency of the motor goes up, your torque goes up, your power goes up, and then when you hit that like midway RPM, it peaks out. Because past that, there's not enough back EMF to really pull as many amps, so your power ends up going down as it continues to accelerate towards the top. So we can look, here's our power. So we have our peak, actually. I should have been saying power the entire time, not torque. Our torque will actually peak at the lower RPMs and go down and down and down in a straight line on a permanent magnet motor as it actually looks. So this test looks like a real motor test to me. And then let's follow this power graph. Power is going to peak at about half of the unloaded RPM, and yes, it does indeed. So let's see, there is our torque side. It looks like we peaked at about 200 Newton millimeters of torque. It looks like they're showing over here. And then our power out is less than 100 watts, 80 watts, something like that. Maybe if we show the data grid, you can look down there. We can just see all the individual points of the data that it streamed out. That's probably a little bit more than we want to know for this test. But what you can do is export that data to a more powerful spreadsheet like Excel or like Google Sheets, whatever they call it. And then you would put a filter on top of this data to smooth it out a little bit more. So what they're probably doing is just averaging this data as it goes along, but we would probably want to do like a second order or a third order filter to really get a smooth line. And those first jumps that happened at the beginning, we could probably filter those out if we did a more powerful spreadsheet to filter the data. All right, we're going to hide that. And that's pretty much it. There's really not much more to do, although I kind of want to try this on a higher voltage and see what happens. So what we're going to do, go to File, go to New. It will ask me if I want to clear all of these tests. I will say yes. We are going to unplug this, and then we are going to get a more powerful battery. All right, for our next test, I'm going to first test once with the 2S battery. We're going to see what that looks like on the graph. Hopefully we get a nice clean graph. And then I'm going to test on a 3S battery back to back, and we will see how much more power and torque this system makes. All right, 2S battery testing. Oh, are you sure ready to set the parameter? Yes, I'm sure. Yep, nice and loud. I'm gonna take this home and do tests at 2 a.m. while my kids sleep. All right, so hey, that's a nice clean grab there from 2000 RPM. I like that. Yes, so we peaked out at 275-ish Newton meters of torque. Our power peaked at, a little bit, almost 90. About 90 watts. But again, we see the power peak at about half of our unloaded RPM, and we see the torque having a nice, almost perfectly linear line as a permanent magnet motor should do. Yes, I like that. All right, first thing I'm gonna do is make sure that this battery is as full as the other one. 12.4 volts. 4.14 per cell. Yeah, that's about a full battery, full enough. I usually charge them to 4.18 volts and not totally make them full at 4.2. Makes them last longer. Totally not related to this video. All right, so we got our 3S40C 3000 milliamp hour battery, 3000 milliamp hour battery from Helios RC. And for this test, I think I need my safety goggles on. All right, are we ready? Are we ready for the 3S? Start sequence for test 2. Are you sure ready to set the parameter? Yes. Whoa! All right. Woo! Woo! I smell something cooking. I smell something cooking. All right. So that was, straight 100% throttle. Not our ESC. That's all I was worried about. That was probably the motor. I didn't even break this motor in first. This was straight off the shelf. Yeah. I smell those brushes burning. So if you really want to test straight 3S voltage applied to any motor, especially brush motors, you should probably break them in first. Yeah, smell's gone. No big deal. No big deal. We don't have any warmth on any of the other equipment, so we're probably golden. But let's take a look at this graph. Ooh, yeah, more power, more torque. So we have a truncated graph on this one. This started data logging at about 4,000 RPM instead of 2,000. But as you can see at this data point, we are rocking instead of, let's see, that one, yeah, more or less 200 Newton millimeters of torque. This is rocking like 225, 230 or so. We could go to the graphs and figure out the exact data points, but I don't really think that's necessary. And then we look at the power. Look at this power graph right here. This was our first test on 2S LiPo, peaked out, not even quite 100 watts. And the next one, okay, we tapped out at what, 19-ish thousand RPM, so we split that in half, somewhere around like 8,500, 9,500. We should see the peak power, and a little bit higher than that, so 11,000 RPM is when we see peak power on here. That's still close enough for horseshoes and hand grenades, honestly, but you can see a huge difference in the power graphs here. We got the green line showing our 2S test, and on the 3S test, it peaks up at 150 or so watts. It's just, yeah, exactly what we want to see for a permanent magnet motor. This is following exactly what we would expect to see from a permanent magnet motor. So my conclusion would be that this dyno is actually giving us good data. Now, how accurate is this data and how repeatable is this data is something that we will learn over the long term. So I can do something like set this motor aside, and if we ever want to test and make sure that we're getting the belt tension right and we don't have bearings going out or whatever, then I would pull this motor back out and I would test it once again. And hey, let's just test it once again on 3S because the smell has subsided. Where'd my safety glasses go? We need safety glasses for this one. Let's go test. Let's go test it one more time. Man, I'm getting excited ahead of myself here. Start sequence. Are you sure ready to set the parameter? I'm sure ready. Yeah. Woo! Yeah. Breaking those motors. Yeah. So that second pull on 3S followed so close. If I was going to throw those into some more powerful graphing software, we could consider those two last pulls to be pretty much identical. We could merge them together if we wanted to get even tighter data. But as we do more and more tests, the motor temperature is going to go up, which means our power is going to go down and our efficiency is going to go down. So we have to be careful about not testing too many times over and over and trusting our data. So, data, what do we call it? I don't know. Why don't you tell me in the description before we end this video on a high note of, hey, success. So I'm going to have a lot of fun with this MiniPro Dyno. I don't know about you, but I'm pretty stoked right now. I am hyped up for another day of work. And it's a Monday like any other day for me. But yeah, success. So I thank you for tuning in. If you do have any more questions, please post them down below. If you want to see more MiniPro Dyno tests, then let me know specific motors. I'm sure y'all are going to have which ones you want to see. Compare all of my motors to each other and then show you, hey, how does the higher quality one stack up to the lower quality one? And that's really what we want to know, because I know how this one stacks up to the other ones in their own category. And although I can tell you that it's nicer and it's going to have higher efficiency because of, face bearing and stronger magnets and all of that, that's something that I don't know if I want to delve into those waters. So again, thanks for tuning in. Have a good one.